Hello class, we are going to start our new unit today. It's going to be on trigonometry. First off, we are going to learn in section 11.1 about the Pythagorean Theorem. You might have heard of this guy before. It's named after the mathematician Pythagoras, who discovered it. So that's why we call it the Pythagorean Theorem. But we use the Pythagorean Theorem to find lengths of sides of a right triangle. So a key there is it has to be a right triangle. It has to have a 90-degree angle in it. And then we're also going to look at kind of working backwards with the Pythagorean Theorem, which is what we call the converse of the Pythagorean Theorem. So the Pythagorean Theorem, if we have a right triangle, remember it has to have that right angle right here, we call the two shorter sides legs. So we have a leg here, and then this long side is what we call the hypotenuse. Kind of a weird word, but the hypotenuse will always be that longer side. So what Pythagoras found is that if you take both of these shorter legs and you square them and add them together, it equals what the long side squared is. So let's say I call this leg A and this leg B, and I call my hypotenuse C. What that's saying is if I take A and I square it and I add to it B squared, it's going to equal C squared. So this leg squared plus this leg squared will equal this leg squared right here. And this is the Pythagorean Theorem, which we will use quite a bit. It shows up on the ACT over and over and over again. So this is a visual I had to show you guys. I don't have a color printer though, so it makes it a little bit trickier with a color print without having color printer. It's all in gray, but kind of a visual here. So I zoom in a little bit. If I have a right triangle and I literally square the sides, I'm putting a square on this short side, I square this middle length side, and then I have my hypotenuse squared right here. If I add the areas of these two squares, it equals the area of that third square, the big square. So that's kind of a visual representation of the Pythagorean Theorem. So the two small squares, if I add them together, will equal that big square. So let's look at some examples. Let me zoom back out. So let's say a right triangle has legs of length 16 and 30. Find the length of the hypotenuse. So they didn't give us a picture, but you could draw one if you want. Remember, legs are the two shorter sides. So let's say this is 16 and this is 30. They want us to find the hypotenuse, which is the long side. So our theorem is a squared plus b squared equals c squared, where these would be your a and b, and then the long side is c. So I'm going to plug 16 and 30 in for a and b. So I have 16 squared plus 30 squared equals c squared. And that's what we're trying to find is c squared. So if I square these now, 16 squared is equal to 256. 30 squared is equal to 900. And that equals c squared. So first we square them. Now I can add them together. So if I add those together, 900 plus 256 equals 1156. And that equals c squared now, but we don't want to know what c squared is. We want to know what c is. So to get rid of a square, we take the square root. So c is going to equal the square root of 1156. So if I put that in the calculator, that equals 34. And so we're saying that hypotenuse is 34 long. So that is how the Pythagorean Theorem works. So just make sure you're doing your order of operations correctly. We have to do the squares first, and then we add them, and then we can start solving for c by square rooting. So that was one where they gave you the two legs and want you to find the hypotenuse, but sometimes they might have a leg missing, and here we have the hypotenuse and one other leg. So you have to remember as you're setting this up that the two short sides are going to be the a and b. Your hypotenuse, the long side, will always be c every time. So don't accidentally set these backwards and say these are your a and b when really this is your a and b. So you have our formula, a squared plus b squared equals c squared. Let's plug in x for a. We don't know what that one is. B will be 10. And then c is 12. And now we're just trying to solve for x. So remember your order of operations, we need to square first. Just going to keep that as an x squared, but 10 squared is 100 and 12 squared is 144. So on this scenario, I can't add x and a number. So to get x alone, we want to solve for it by subtracting that 100 over so that those cancel. And we just have an x squared left on the left side. And then 144 minus 100 is 44. And then now we can get rid of the square by square rooting. 44 is not a perfect square, so we can't just throw it into our calculator. Depending on how they want it, most of the time they'll want you to do the radical form, which means to have the square root on it. So if you remember at the beginning of the year, we learned how to do the little factor trees and break apart these square roots. I want to find a perfect square that goes into 44. So I know 4 is a perfect square, and 4 times 11 is 44. But the reason we're doing that is because I can take the square root of 4. The square root of 4 is equal to 2. But then 11's prime, there's no perfect square for it, so we just keep these two pieces and we say it's equal to 2 square root 11. And that would be your answer. And then sometimes they might want the decimal. If they want the decimal, you can just throw it in your calculator. But the decimal for that would be about 6.63, and it just keeps going. So just make sure you're paying attention to, do they want radical form? This is radical form, means it has a square root. Or if they want a decimal, they'll tell you what decimal to round to. So that's kind of your giveaway there.